friends, in this video series we have been discussing about eukaryotic DNA replication. In this video we are discussing about the termination of DNA replication in eukaryotes. Can we start? Eukaryotes DNA is linear fashion. These two strands, you can see in this diagram, these two strands running in opposite direction. That means these two strands running in 5' to 3' direction, and this is in 3' to 5' direction. Okay, and these two strands running in opposite direction. Most of the time replication forks terminated. Two replication forks encounter when the two replication forks, you can see in this diagram, when the two replication forks encounter each other, where the replication is terminated. Okay, in this diagram you can see the MCM complex. In this diagram you can see the MCM complex. MCM is the helicase in eukaryotes. We already told about helicase in eukaryotes is MCM 227 complex. MCM 227 complex is the helicase in eukaryotes, and this MCM complex approaches each other. With this helicase, the other proteins are associated with it. With this helicase, other proteins are associated with it, and there is lots of ORIC site. There is lots of ORIC site is present in the in the eukaryotes. There is lots of ORIC site present in the eukaryotes, but in the prokaryotes only one ORIC site is present. Let's see that upper right corner. You can see the upper right corner is in 5' to 3' direction, 5' to 3' direction, and this is the leading strand. Upper right corner is in 3' N, free 3' OH is OH, 3' OH is present, hydroxyl group is present, where the other polymerase extended the nucleotides. Polymerase we added and extended the nucleotide. That's why it is the leading strand. And the lower side you can see it is in lagging strand. Lagging strand is present in the lower left corner. In the lower left corner also the leading strand, free 3' OH is present, 3' hydroxyl group is present, and it is polymerized by the polymerase enzyme. Okay. Furthermore, you can see the lagging strand where the multiple primers are present, where the leading strand only one primer is present, but in the lagging strand multiple primers are present and continuously added the polymerase for synthesis of nucleotides. Okay. This concludes the DNA replication elongation process, and then two MCM complex will converge. Then you can see here that then two MCM complex is converged here, and where SCF-E3 ubiquitin ligase complex is present. Where SCF-E3 ubiquitin ligase complex is present. SCF means the escape-1 CDC53 culin F box protein. SCF means the escape-1 CDC53 culin F box protein. This protein comes and catalyze the ubiquitination of MCM protein on its 7th position. The helicase protein is 7th position. Helicase 7th position. It's SCF-E3. That means the SCF catalyzes the 7th position of the helicase protein. Okay, catalyze the 7th position, and where its lysine residues are called K48 ubiquitin chain. K48 ubiquitin chain, and K is the lysine, and in this case ubiquitinated protein did not degraded in this case, but always ubiquitinated protein, what happens, ubiquitinated protein is taken to the proteasome and ubiquitinated okay. In here ubiquitinated protein is recognized by P97 protein, and P97 is the protein remodeler is the P97, and P97 is transitional endoplasmic reticulum ATP. P97 is transitional endoplasmic reticulum ATP, and also known as velocin containing proteins, and also known as segregase protein. It's also called segregase protein. You can see that this is SKP SCFEC SKP1 CDC53 Curin F box protein. You can see here, and ubiquitinated at the 7th. Okay, then ubiquitinated MCM is instantly recognized by P97. You can see in this picture, P97 is the velocin containing protein. P97 is the velocin containing protein, and it causes disassembly of MCM complex. It causes the disassembly of MCM complex. It is a CMG complex. It segregates MCM complex. CMG means CDC45, M means MCM227, G means genes protein. CMG complex, it segregates the MCM complex. Means which segregates? Yes, we know that P97 segregates protein, and it segregates the CMG complex. CMG means CDC45, M means MCM227, G means genes proteins. So this CMG is no more reactive bone state, active bone state. It's no more active state, and all cofactors are removed from these strands, and thence it is terminated the DNA replication. That's why this CMG complex no more active bond state, and the replication is terminated, and all the cofactors are removed from these strands, and replication is terminated. You can see in this picture, this helicase is removed from the site and replication is terminated. You can see the Curin SKP1 complex and F box protein and ubiquitin here. This is the bound state, ubiquitin bound state. Okay, and the helicase is removed from here, and the DNA is getting terminated. Then it's all about the DNA replication termination in eukaryotes. In the previous video we have already told about the DNA replication initiation and elongation, and that's all about the DNA replication process. And in next video talking about we will be talking about the transcription, translation, etc. Okay, keep watching my channel. Thank you very much, guys.